Next one. You are standing 100 feet from the base of the building. The angle of elevation from the ground to the top of the building is 48 degrees. What is the height of the building? So I have my picture. Standing 100 feet from the base of a building. So if I imagine that this red line here is the building, I'm 100 feet away. The angle of elevation from the ground to the top of the building, so from the ground to the top of the building, angle elevation is 48 degrees. And it's asking me what the height of the building is. Well, if I take a look at the angle that I'm given, I know that H is the opposite side and that the 100 feet away is my adjacent side. So to find the height of the building, I will use my trig function that has opposite adjacent, which is tangent. So the tangent is opposite over adjacent. I plug in the values that I know. Tangent of 48 then is equal to H over 100. Since the variable is on top, I multiply by 100 on both left and right. Cancels out where I need it to go. And I'm left with the height of the building as 100 tangent of 48, or approximately 111.06 feet. There's the height of the building. Alright, next one. States a driveway rises 12 feet over a distance d at an angle of 3.5 degrees. What is the estimated length of the driveway? So I have a driveway that rises 12 feet over a distance d. So the length of the driveway is unknown, it's d. And wherever it started from here on the end, it goes up 12 feet over a long distance. So probably more gradual than the picture shows. But in any event, the question is, what is d, or the length of the driveway? From my 3.5 degrees, I notice that 12 is in the opposite spot and d is in the adjacent spot. So again, opposite adjacent, I will use tangent. Filling in the pieces that I know, it'll be the tangent of 3.5 is equal to 12 over d. And now we're back to the problem where I have the variable in the denominator, so therefore I'll multiply d on both sides, and then I'll cancel it out and I'll divide both sides by the tangent of 3.5 on both the left and the right, giving me my variable solved by itself. So d tangent of 3.5 is equal to 12, divide both sides by tangent of 3.5, and I'm left with d is equal to 12 over the tangent of 3.5, or approximately 196.198 feet for the driveway. So again, if the denominator has the variable, you need to multiply the variable on both sides and divide by the trigonometric function. Good. Similar type problem. The bottom of a handicap ramp is 15 feet from the entrance of a building. If the angle of the ramp is about 4.8 degrees, about how high does the ramp rise off the ground to the nearest inch? So we are looking for that value x. I do not have the opposite. I do have the adjacent, so therefore I'll use tangent. I will have the tangent of 4.8 is equal to x over 15. I will take and multiply both sides by 15, so I have x is equal to 15 tangent of 4.8, or approximately, grab your calculators and solve. Okay, my final value will be 15 inches, rounded to the nearest inch. If you wanted the actual value of 15 tangent of 4.8, it's about 1.26 feet, which simplifies down then to about 15 inches. Okay, similar type problem. Alright, new concept, inverse trigonometric ratios. So reading the first one, it says if A is an acute angle and the sine of A is x, then the inverse sine of x is the measure of A. And then symbols, if the sine of A is equal to x, then sine inverse of x is equal to the measurement of A. Inverse trigonometric functions find the angles of right triangles. And there is one for both cosine, for all of them, sine, cosine, and tangent. And you should look on your calculator. It will have the inverse trig functions listed there, probably above the sine, cosine, and tangents buttons. Let's show you an example so you know what we're talking about. question says, use a calculator to find the measure of angle D to the nearest tenth. Well, angle D is down here. From this angle D, I have 16, which is the opposite side. Across from the right angle is my hypotenuse. And just like at the beginning of the lecture, we talked about using the trigonometric ratios to solve for something. We have the opposite hypotenuse, which is sine. We know that the sine of D is equal to 16 over 23. Now, to solve for the actual numeric value of D, what I need to do is put it into inverse, use inverse trig. So inverse is just like everything else. Cancel out one side. So if I want D by itself, I can take the sine inverse of sine of D on both the left and the right sides of the equation. On the left side, the two sine and the sine inverse cancel out, and I'm left with just D is equal to sine inverse of 16 over 23. And if you type that right in your calculator, you will get the value of angle D right out. So you're probably going to press the second button on your calculator, second sine inverse of 16, and then 2 over 23. You'll end up with a degree measure of approximately 44.079. It wants it to the nearest tenth, and we're sitting here the only one, which is A. So that is using inverse trig. Alright, next example here. It says solve a right triangle. So now the goal of a problem given to us is not only to give out a side length or an angle, but to give you every piece of the right triangle. So given right now we have 8 and 10, we can solve for C using the Pythagorean theorem if we'd like to start with, but then we do need to use reverse trig, or inverse trig, excuse me, to solve for A and B. So before I'm done with this problem, I need to have both angles A and angle B solved for, as well as side length C. Let's start with, of course, C. So using Pythagorean theorem from before, we can say that C squared is equal to 8 squared, which is 64, plus 100, which is 10 squared. And then we simplify and solve, and C is equal to 2 square root of 41. Solving for angles A and B, depending on which way you're looking at it, from A, this is 10 is the opposite side, and from B, 8 is the opposite side. So whichever one you start with, that's where we have to go. We can use tangent, of course, if we want to solve for A, and the tangent of A is equal to 10 over 8. Using inverse trig, we can solve then and get A by taking the tan inverse on both sides, left and right, which will give us A equaling tan inverse of 10 over 8, which is approximately 51.34 degrees. So that gives us angle A. Once we have angle A, okay, what I would like you to do then is to solve for angle B. And I don't want you to use the fact that the triangle adds up to 180 degrees, so subtraction. I'd like you to do the trigonometric function for B as well. So tangent of B is equal to 8 over 10. Taking the inverse tangent of both sides and solving, angle B is approximately 38.659 degrees. So that is solving a right triangle given two side lengths. Let's now solve one that has one side length and one angle. Here we can use the fact that sine, or the angle S is going to be 70 degrees by using this fact that the angles add up to 180 degrees, and we'll use trig to solve for both R and S. So of course, once we have one angle and one side, we can solve for the other side. Sine of 20 is equal to R over 15. Multiply 15 on both sides. R is equal to 15 sine of 20, or approximately 5.13. Same thing for something for S, except we're using cosine because S is on the adjacent side. So using adjacent hypotenuse, we'll have cosine of 20 is equal to S over 15. S then is equal to 15 cosine of 20. And like I said before, solving for angle S is pretty straightforward. Angle S is equal to the entire triangle 180 minus 90 minus 20, or 70 degrees. So that's solving a right triangle given one side and one angle. Alright, last example. It says solve the right triangle. Round side measures to the nearest tenth and angle measures to the nearest degree. So to solve the right triangle, what we're going to have to do is use trig to start with. So we'll use the opposite and the adjacent from angle A. That'll give us the tangent of A is equal to 11 over 8. That leaves us with tan inverse of 11 over 8 is equal to A, which then is approximately, if we take our calculators and type that in, we have, again, tan inverse of a 11 divided by 8, approximately 53.97. So that is for angle A. Okay, and there are two we can get rid of right away. That'd be C and A. And now we're left with side B and side C. So angle B and side C that we're trying to solve for. Correction on that. To solve for little c, we use trig. So we will have 64 plus 100, sorry, not trig, Pythagorean theorem. 64 plus 121 is equal to c squared. So then we have 185 is equal to c squared. And the square root of 185 then will be c is approximately 13.6, which leaves us with b as our only other answer. We could solve for angle B and get around 36, but b as a choice here is the only one that has angle A and side length C. And there it is. So that's solving a right triangle. That ends lecture for today. Problems that we will look at from this section are from page 567, 1 through 6, 8 to 21, and 28 through 44. Thanks for watching.